I'm Associate Professor Jonathan Bossenbrock. I work at the University of Toledo. I'm in the Department of Environmental Sciences and work at the Lake Erie Center. I've been at the University of Toledo for about 6 years, and my research efforts are primarily on the spread and distribution of aquatic invasive species. My past in terms of invasive species work starts back with my master's work, which is 12, 13 years ago now, where I built a model. I was at University of Wisconsin Green Bay working with Cliff Kraft and Jeff Nicola. We developed a model to look at how well we could match the pattern of zebra mussel spread in the Great Lakes Basin based on recreational boater movement. So that paper got published, and the editor for that paper was David Lodge at Notre Dame. I went off and did my PhD work on grassland beetle and bird work, but I maintained contact with David Lodge. So he was the editor on that paper, and he actually wanted some of my data, so we kept that relationship going, and then we worked on some grants to get me funded to do a postdoc with David Lodge. And so that brought me to David Lodge 8 years ago, where I worked on basically the question of what is it worth to keep zebra mussels out of the western United States. We initially proposed to do Colorado Basin, Columbia Basin, and Sacramento-San Joaquin Basin. Because of budget issues, we focused on the Colorado Basin and the Columbia Basin. Most of the economics work that we tied in with this were at the Columbia Basin. There was basically two questions. One is, can they live there? And two, can they get there? And the first, can they live there, was a paper that was actually, the lead author was John Drake, who's now at the University of Georgia. We used what's called a niche, ecological niche model. We used a software called GARP. And that tool matches known locations of where an organism lives and tries to predict those same kind of environmental factors elsewhere. So the model kind of fits where zebra mussels existed in the United States and trying to predict where else in the United States those places exist. The short answer was where they currently are is a good place for them to live. Out west was very heterogeneous. You got a lot of different geology going on and climates going on out west. So, the predictive power was that, yeah, there are some places that are good, but it's fairly variable. And the second question was, can they get there? And so then we tried to develop a model, and this was work with David Lodge, Ladd Johnson, who's now in Canada, a couple other people, looking at, can we model how recreational boaters move throughout the entire country and thus predict who is bringing or potentially bringing zebra mussels or quagga mussels from the Great Lakes Basin, or anywhere actually in the eastern United States, out to these western basins. And that was an interesting paper because we predicted, so there's a lot of big reservoirs in the Great Plains areas that still don't have zebra mussels, but that model predicted that Lake Mead would have been more likely to be invaded than some of those Great Plains Basin lakes. And just when I got done with the galley proofs for the publication, 2 weeks later, they showed up in Lake Mead, and unfortunately I wasn't able to go back and make modifications to the paper because the galley proofs were already done, but it was very much an indication that our model to some degree was working. I mean, there was places my model predict that were more likely, but it showed up in a place where there was other places that we predicted closer to the Great Lakes, such as in Nebraska and Kansas, where they still hadn't shown up, and that we had predicted that Lake Mead was going to show up before those. So to be able to predict where zebra mussels could live in the United States, most of these tools that were predicting future distributions of species were mainly terrestrial organisms. So this was a different ball game because climate is not as big of a deal because you're dealing with aquatic systems and water temperatures are more stable. There still is a climate issue, but obviously moisture is not as, precipitation is not a big issue because if there's water there, there's enough precipitation to keep that water there. And things like zebra mussels, they need certain water quality characteristics, a certain pH, a certain level of calcium, and to try and predict those kind of measurements for all the way across the country is hard to do because people don't measure pH and calcium for all the lakes across the country. pH you could probably get a good handle on, calcium not so much. So we needed to find some other like surrogate variables, and so we included things like geology, bedrock geology, surficial geology, to try and deal with that. We included other climate variables, precipitation, temperature, elevation, frost-free days, and so forth. But we really spent a lot of time trying to make sure we had something that represented the water quality, and that being at that scale, at the scale of the entire country, we put in geology. If we were doing a smaller scale, or if we had more time, more money, and the data was actually there, we'd like true water quality data for any lake we were interested in. So, our model was a very large scale coarse brush kind of thing. If you wanted to go in and take each individual lake, Lake Roosevelt, the Columbia Basin or river in particular, then you'd want to go out and measure those variables in particular. To get at the question of can zebra mussels get moved, or Dreissenid mussels I should say, get moved from areas with Dreissenid mussels to other places, we wanted to look at boater movement patterns. And we did it at a scale of, we broke up the country into 210 watersheds. And we use what's called a gravity model. And now, so geographers use these because people make a decision about where they go based on two coarse variables, distance and attraction. So something, just like gravity works based on distance, and that gravity or size or mass, that attraction, things pull together, we can think of human decision making on that attraction being some variable. For us, it was lake size. There's lots of other things that go into attraction to whether you go to a certain lake, fishing quality, accessibility to cities or state parks. But again, at the national, trying to build a model at the national scale, we wanted course level variables, so we looked at lake size. And so we were trying to predict, how many boaters from a particular watershed, such as in the Great Lakes Basin, were traveling to places out west. So you had this framework of where our model built, tried to predict how many boaters were going from each water basin to some other basin across the country. And again, most boats stayed in their same watershed. So the question was, can we get a hold on these long distance rare, and can we parameterize the model so that picks up some of these rare long distance movements? And so we did use survey data, such as survey data from the 100th Meridian Initiative, to parameterize our model to look at how many boaters are actually going from the Midwest through Kansas and beyond, to make that model fit. And so our model still said that most boaters are traveling locally, but we do have some of these long distance boater movements that our model was able to capture. The Colorado was very important because you got Lake Mead, Lake Powell, Lake Havasu, some big water bodies that are very popular destinations. But the interesting thing was, as opposed to being a wave front, where first they'd have to stop off in Kansas and then the Colorado reservoirs and then getting into Utah and then down into Arizona, our model said that no, there is a prediction that it'll jump over all these Great Plains reservoirs and even Colorado reservoirs and get into Lake Mead first, or before some of these other ones. I mean, there was other lakes in the eastern United States that our model said should have shown up first. The Harry Truman Reservoir in Missouri was predicted to become invaded before Lake Mead. Lake Mead became invaded before it did. But these are probabilistic, so it's, I think the Truman, or at least the reservoir below Truman is now invaded. I don't think Truman is yet, or last I checked. But yeah, in terms of out west, the Colorado was the, kind of one of the primary destinations where we thought things would show up first. So in terms of the risk to the Columbia Basin, the geology there is very heterogeneous, so you have a lot of igneous bedrock and things like that, which aren't known to support zebra mussels very well. But you're also draining agricultural land, so you do have areas that have plenty of pH and calcium, such that could support zebra mussels or quagga mussels. The thing that's the biggest risk out there is that you have a lot of infrastructure. You have all these dams, you have pumps to feed that agriculture. So you have lots of things for zebra mussels and quagga mussels to attach to clog up that would cost a lot of money. And so we actually worked with some economists, Dave Finoff of the University of Wyoming, Travis Warzinski, who's now at University of, he was in Heidelberg, Germany, and now he's back in the US, and I can't remember where he is. But so they looked at what would be the economic impact to the Columbia Basin if you had a full-blown Dreissenid outbreak. And what they do, instead of just tallying up costs, so how much would it cost to clean screens every year, I mean, that actually pays, if you have to clean a screen, that's an increased cost of the power plant, but somebody else gets paid to do that. So to some people, it's a benefit. And so what they look is how it changes the overall welfare of the system. And what that means is that it changes where people really want to spend the money. I mean, the highest welfare in any society would be, well, we're all spending the money exactly where we want to spend it and get the most value out of spending it. So some people, when you have invasive species show up, some people are still making money. And it's a good thing for them. Other people are spending money where they don't want. So that issue of welfare, for me, was a hard thing to grasp. For me, it was just like, how much does it cost to clean a trash rack? And what the economists suggested was that if you had a full-blown invasion in the Oregon Basin, it would reduce the welfare of the basin by something like $5 to $6 million a year. And now, for the power companies, that may not be a whole lot of money. For me as an ecologist, that's a lot of money. For anybody, at most kitchen tables, that's a lot of money. The question is, and the issue is that these power plants can just distribute that to all their customers. So for the power plant, it may not be all that much money, but for the whole economy, you're losing, you're spending $5.5 million a year on things you don't want to be spending the money. And that's just one number out there. So we needed something to compare it to. One of the most extreme scenarios that you could compare that to would be not allow anybody to bring a boat into the basin. So stop all fishing or fishermen that were from outside of the basin. And so that was kind of the scenario we compared it to. And that actually would cost the basin more. You would lose something like $15 million per year in welfare if you kept all those people out. So tourism is a big benefit. But the thing is, we were only looking at direct market costs, the impact to, the power plants. We didn't include any potential impact to the salmon fishery. Those salmon runs, if you got zebra mussels on all those fish ladders, how much damage would that do to those fishes? How much damage would it do to other natural systems out there? So all those secondary costs we didn't include. We only include the one cost of the power plants, and that was, let alone $5.5 million a year. And stopping all the boaters, that's an extreme measure. That would cost $15 million. So trying to find that balance of restricting access, or at least checking access, what is it worth to stop and look at boaters, that becomes the question, I think. So the model we did was, if zebra mussels were hitting all the federal power plants to kind of at a large abundances. So our scenario was that zebra mussels would be impacting all those dams at a high level. And now, so there is some debate there, but we were only looking at those costs. So there's two issues, I think, in terms of, we were looking at the extreme case for impact of power plants, but we didn't include any of the other impacts. So, so I think it could be less cost because zebra mussels may not do well in all the reservoirs or at all the power plants. But it certainly could easily be more because zebra mussels have lots of other impacts than just on a power plant. Like I said, on fish ladders, on the ecosystems in general. So the balance is, there's a lot of complexity there that, we're just starting to try and integrate these disciplines of invasive species invasions and economics, and very few groups are doing that, and so we're trying to get better numbers, but this is what we got so far. We're working on a grant to look at how invasive species impact the food web of the Great Lakes and therefore the Great Lakes economy. And one of the things is, important that is, again, is spread. So we're looking at spread of shipping of the Lakers. A lot of people have looked at shipping coming into the Great Lakes, but not necessarily how the ships that move just within the Great Lakes move invasive species. We have the recreational boating issue. We have bait issue. The bait industry is very unregulated in certain states. It's better regulated in other states. So understanding how if a fish disease showed up in a certain place where people collect bait, how quickly would that get moved throughout the bait network? We don't know that yet. And so those are issues we're looking at. What species we're going to end up focusing on is being driven by the managers in this region. We want to be able to serve those managers, and they're still talking about and debating about what species we want to focus on. Obviously, a big one these days is Asian carp, so we'll probably be focusing on that. But another really good one to still focus on is Dreissenid mussels, because there is a good record of where they showed up and when they showed up. So when we build our models, they're a very good test organism to make sure that our models work right. And so if we can predict where zebra mussels moved around the Great Lakes since they've been here for so long, at the rate and the timing in which they did, then those models should be good for when we say, okay, we have a new thing coming in. If it shows up here, where is it going to go next? So especially in the Midwest now, zebra mussels are a very good model organism for testing the models to begin with.